And so on homework 8, this first page is just common mistakes that students make is they confuse sequences and series, right? So this is just a page on sequences. So the goal is to figure out whether these sequences, I'm going to say that like that every single time, converge or not. Really easy to do, right? So all we need to do to see whether a sequence converges is take the limit as n goes off towards infinity. So if we take the limit as n approaches infinity of the natural log of n over 2n, right? So we know that 2n increases faster than natural log of n does. This is going to be 0. So this sequence will converge. All right, so if I looked at question 2, I'll do like 10 of these, 8 of these. I'll do, I don't know, I'll do 4 of these things. So same thing for question 2. We would take the limit as n approaches infinity. So we want to rewrite this a little bit because we have factorials, right? So n factorial over n plus 3 factorial, right? So you might know that this is going to be larger, right? So it's going to dominate. But if not, we want to take the larger factorial, n plus 3, and then use this recursiveness until we get the smaller factorial, right? So n plus 3, n plus 2, n plus 1, and then there's our n factorial. So we can cancel these n factorials. And now we're taking the limit as n approaches infinity of 1 over n plus 3, n plus 2, n plus 1. The only places that our n's live is on the bottom. So this would converge. So it converges to 0, the sequence. So same thing here. This one's not going to be too bad, right? So if I took the limit as n approaches infinity of 5n squared 1 minus n cubed, right? So the bottom dominates the top because we have a cubic versus a quadratic. So this is also going to converge, aka as we get far enough out, right? The values in the sequence don't really deviate from 0. Here we want to be a little careful, right? So if I look at the limit here, so the limit as n approaches infinity, if I just didn't look at this -1 to the nth power, I would just have n plus 1 over n, and this would approach 1. But what's happening because of this -1 to the nth power? Well, suppose n was some really, 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 really big even number, right? -1 to the even is going to equal +1. So the limit as a really large even number approaching infinity is going to be +1 times 1, right? That 1 that we just found there. However, if -1 is raised to an odd number, it's going to be -1. So if we took the limit as n approached infinity, now n is odd, we're going to get -1 to an odd number times the same 1 that we had. So this is now going to be -1. So this is going to fluctuate between positive and negative ones. So this sequence will diverge. I'll do the next 4 in the next video and stop saying sequence like a weirdo.